All right, let's dive in. Today, we're going to pull back the curtain on one of the most important ideas in all of tech: system design. This is literally the invisible blueprint that makes our entire digital world tick, and we're going to figure out exactly how it works.
I mean, really think about it for a second. How is it that you can hit play on a Netflix show and millions of other people can be doing the exact same thing, and it just works? Or you send a WhatsApp message and it appears on the other side of the world instantly. That's not magic. It's a series of incredibly smart decisions. That is system design.
So here's our game plan. First, we'll nail down what system design actually is and, why you should even care. Then we'll get into the fun stuff, the core building blocks, the step-by-step process designers use, and finally, we'll see it all come together in the real world. Okay, so let's get right to the heart of it. What is system design? Well, the easiest way to think about it is as the master plan, the grand architectural blueprint for any piece of software. What this really means is, long before anyone writes a single line of code, designers are sketching on a whiteboard. They're figuring out all the moving parts. They're asking the big questions. What are all the pieces we need? How are they all going to talk to each other? Where are we going to store all the data? It's the blueprint that makes sure the house will actually stand up. And this blueprint really comes in two flavors. You've got the high-level design, or HLD. That's the architect's view, the big picture sketch of the whole building. Then you have the low-level design, the LLD, which is more like the builder's view, the detailed plan for every single component, every single room. You absolutely need both to build something that lasts. So why bother with all this planning, right? Why not just jump in and start coding? Well, it's because a good system design makes some really important promises to its users, promises that go way beyond the app just, working. And those promises are what we call the 5 pillars. Scalability means it can grow from 1,000 users to 1 billion without breaking a sweat. Reliability means it's not going to crash right in the middle of the Super Bowl. Performance means it's fast. No one wants to stare at a spinning wheel. But here's the kicker. These pillars are almost always fighting each other. If you want more performance, it might cost more. If you want more reliability, the system gets more complex. The entire game of system design is about finding the right balance between these demands. Okay, so to actually build something that can deliver on those 5 pillars, designers have a whole toolbox of powerful concepts and technologies. Let's pop it open and look at some of the most crucial ones. Let's start by zooming in on that first pillar we mentioned, scalability. This is the direct answer to our first question about how massive apps handle all their traffic. This is how you plan for wild success right from day one. Now, designers really have 2 main ways to scale up. There's vertical scaling, which is like making one superhero stronger. You just beef up a single server with a better CPU or more RAM. But eventually you hit a wall. So then there's horizontal scaling, which is like adding more superheroes to the team. You just add more and more servers. This is how the giants, your Googles, your Facebooks, do it. They scale out. Next step in the toolbox, the database. This is the brain of the entire operation. Every single piece of data, your username, your photos, your viewing history, it all lives in the database. And let me tell you, choosing the right kind of database is one of the most critical decisions a designer will ever make. The choice usually boils down to this classic dilemma: SQL versus no SQL. Think of a SQL database like a super meticulous librarian. Everything is perfectly organized in neat rows and columns. This is amazing for things that have to be perfect, like bank transactions. No SQL, on the other hand, is more like an artist's studio. It's flexible, a little chaotic maybe, but incredibly fast and easy to scale. It's perfect for the messy, unpredictable data you get from a social media feed. And right there, you see it, a classic trade-off. Do you want perfect structure, or do you want flexible speed? Now, hitting that main database for information every single time can get really slow, and that's where our next tool, caching, comes in. You can think of a cache as the system's short-term memory. It keeps the most popular, most frequently used data right at its fingertips, ready to go at lightning speed. So really, a cache acts like a protective shield for the database. It handles all the common, repetitive requests, which frees up the database to do the really important work. And what does that mean for you, the user? A way faster, way more responsive app. Okay, so we've seen the tools in the toolbox, but how do designers actually put them all together? It's not just random. It's a structured, methodical process that turns a simple idea into a solid piece of architecture. It usually follows these 4 main steps. First, and this is the most important part, you have to understand the requirements. And that's not just what the system has to do, but defining things like it has to serve 1 million users and respond in under 200 milliseconds. That sets the target. From there, you can define the overall architecture. Then, you design the database. That's where our SQL versus no SQL decision comes into play. And finally, you layer on all the optimizations, like caching, to make sure you actually hit the performance goals you set back in step 1.
All right, enough theory. It's great, but let's make this stuff real. Let's see how all these building blocks and processes actually come together to power the apps that we use every single day.
Let's look at a few examples. For a URL shortener, the biggest challenge is just generating billions of unique links without collisions. For WhatsApp, it's all about delivering messages instantly, in real time across the globe. And for Netflix, their main problem is streaming massive video files to you reliably, no matter where you are. See, each system uses a totally different mix of our building blocks to solve its own unique challenge.
And that brings us right back to what is probably the single most important idea in all of system design. It's not about memorizing diagrams or finding the one perfect answer, because spoiler alert, there's no such thing as a perfect system. It's all about making smart trade-offs.
Every single choice you make is a balancing act. Are you going to go with the rock-solid consistency of SQL, or do you need the raw speed and scale of no SQL? Are you going to spend more money to scale up a single big server or deal with the complexity of managing a fleet of smaller ones? That is the art and the science of system design.
So, I'll leave you with this little challenge. The next time you open your favorite app, to stream a movie, post a photo, or order some food, just take a second and think like a system designer. Ask yourself, what invisible choices, what clever trade-offs are happening behind the scenes right now to make this whole experience